Bismillahirrahmanirrahim. Assalamu students. I'm Sabir Hasnan, your science subject teacher from grade 8. If you remember, in previous videos we discussed about electricity and energy from chapter number 7, and over there in the first video we discussed about law of conservation of energy and Sankey diagrams, and in the second video we discussed about power supplies and voltages. So over there we discussed different kind of sources, and later on we discussed about how we can measure the voltage from using a voltage source, I mean the voltmeter. So now our aim is to discuss about resistance and further how to control the flow of current. I hope we will discuss in the same video or the later on in next video. So resistance is actually the measure of the opposition to the flow of current in an electric circuits. So in other words, resistance is measure of the opposition to current flow in an electric circuits. Let's suppose we will discuss this concept with the totally different example. If we are on a straight road towards the school, and over there would be no traffic, definitely we will not feel any opposition or the rush. There would be no rush, and then we can move very easily and smoothly to our school, or when you are coming back to your home, the same way you will move easily. But in different case, let's suppose if you are in some area like in Salala, so over there that is a public place, that so there would be a huge traffic over there. You can't move smoothly, you can't move fast, you feel some opposition, so it's not easy to move fast or drive fast over there. So actually that area opposes your motion. Exactly like that, resistance actually is the opposition to the flow of electric current. So the unit, now question is, the unit of resistance is ohm. Keep one thing in mind, resistance is represented by R. Sometimes, mostly it is represented by capital R, and sometimes it is represented by small r, in some cases. So resistance is measured by ohms, and the symbolic form of the unit ohms is actually omega, and it's a Greek letter omega, and ohm are named after the George Simon Ohm, a German physicist who studied the relationship between voltage, current and resistance. That is the famous relation V equal to IR, which is Ohm's law as well. So keep in mind V equal to IR, which is Ohm's law as well, and the unit of resistance is ohms, represented by omega, or this is the symbolic form omega, which is a Greek letter. Okay, now question is this: what are the factors affecting on resistance? There are two main factors which are given in your book, but here we are going to discuss 4 factors which are given in the figure or in a table below. So in book, those 2 factors are the thickness of the wire. I mean, look at here, it's a thick wire, and look at the second one, it's a thin wire. So actually it is related to the cross-sectional area. A thick wire has more cross-sectional area, a thin wire has a small cross-sectional area. Okay, and if we discuss a thick wire and thin wire, we can easily understand, or we can easily relate resistance and current uh, by using the example of water pipe. This is an easy way to understand the resistance and current by using water pipe. Look, if we have a water pipe which is thin, okay, so in a thin water pipe a small amount of water will pass or flow, but in a thick pipe a large amount of water can pass and flow. So in other words, when there is a large amount of water passed through a thick pipe, it means resistance would be small. That's why the water moves easily. Okay, if we relate it to the current, so in a thick wire current will pass easily and wire offers a small resistance, but in a thin wire current moves bit slowly, and because the resistance is greater in this case. Okay, now in the second example, in the second a factor which affect resistance, that is the nature of the material. I told you in the class, if we take gold, silver, copper, aluminium, then gold will pass the more current, okay, because it has a nature to offer the least resistance. So similarly, in case of silver will offer bit more resistance as compared to gold. So in short, here if we take the example of copper and iron, both will offer a different resistance, and when they offer a different resistance, so that material which offer less resistance will allow more current to flow, and that material which offer more resistance, that will allow less current to flow in the circuit. These are the two major things which affect resistance. Third point, which is not given in your book, that is length. If there would be a small length, then resistance would be small, and if there would be a larger in length, the resistance would be greater. So due to the increase in length, resistance increases. Due to the decrease in length, resistance decreases. So in case of length, resistance is directly proportional to the length. In case of cross-sectional area, resistance is inversely proportional to the cross-section area. Greater the area, smaller the resistance, smaller the area, greater the resistance. Now come towards the fourth point, which is temperature. Look here, the temperature is small. When temperature is small, resistance would be smaller, and when temperature would be greater, resistance offered by a conductor would be greater in magnitude. So the conclusion in this case, let's suppose if some wire is at 30 centigrade, that offers a less resistance as compared to that wire which is at 50 centigrade or 100 centigrade. In case of 50 or 100 centigrade, the temperature is greater as compared to the 30 centigrade. So that will offer more resistance. Now the next point, look, whenever the resistance, there would be a resistance that actually cause the heating effect. Okay, so the heating effect is actually due to the resistance as well. So if let's take the example, if we will take the example of electric iron. Okay, so in case of electric iron, when you will switch on the main supply, after some time the base of the electric iron, the temperature of the base of electric iron increases. What is the reason behind it? Because this is actually the heating effect. Okay, and the heating effect, this heating effect is due to the high resistance. So whenever the resistance increases, definitely the temperature of that specific object increases. We can apply this application or this result in electric fires, electric irons, electric toasters, and electric kettles as well. Heating effect also occur in case of light bulb as well. Whenever we switch on a light bulb or tube light or electric fan, if you touch that after some time when it was switched on, let's suppose if you touch a light bulb, if you touch a tube light, you will feel the temperature of that tube light or that bulb is bit higher as compared to when they are switched off. So this is basically the heating effect. The resistance increases the temperature of an object as well.